The day 6 of Advent of Cyber. Today we are dealing with malware analysis. Why? Let's dive into the story and identify why we are looking at malwares today. The story. The town of Wareville remains quiet in the middle of the night, while the residents of the Wareville are nicely tucked up in the bed, blissfully unaware. The SOC team at the Best Festival Company remain alert, poised and ready for whatever may face them. Monitoring their screens, armed with freshly poured mug of hot cocoa, the elves of the SOC watches their dashboard diligently. Suddenly, the elves receive an email in the Union Sun from Elf McClaws, head of Elf Affairs, in their inboxes. It reads, from Elf McClaws, subject, a new schedule awaits. Attachment, hophelper.exe. To all elves going forward, we will be using a new program for creating and viewing the team rosters. The new program will revolutionize how rotors are made here at the Best Festival Company. Please contact IT support if you have issues running the program. Kind regards, remain the best. Elf McClaws, head of Elf Affairs. Why is Elf McClaws working at 3 a.m.? Screams a member of the SOC team in the background. They're right, something is amiss. Elf McBlue is immediately suspicious. Their years of experience of SOC have given them the wisdom to not download out of the blue executables. Without McSkiddy's wisdom, Elf McBlue takes charge. Loading up their malware investigation toolkit, the investigation begins. Today's room will have you taking the place of Elf McBlue, a highly talented member of the Best Festival Company's malware investigation squad. You have been tasked with investigating a highly suspicious executable that is being shared within the company. In today's room, we'll be covering the following: the principles of malware analysis, an introduction to sandboxes, static versus dynamic analysis, and tools of the trade: PeStudio, Mon, and Regshot. Okay, so they've given us the details of what and all do we need to turn on today, and I have done that here. So let's scroll down and click on check. Then, okay, these streaks, all those things, let's just put it down. Principles of malware analysis. Malware analysis is the process of examining a malicious file to understand its functionality, operation, and methods for defense against it. By analyzing a malicious file or the application, we can see exactly how it operates and therefore know how to prevent it. For example, could the malicious file communicate with attacker's server? We block that server. Could the malicious file leave traces on the machine? We can use these to determine if the malware has ever infected another device. Instead of fearing malware, we can take a proactive approach for translating technical findings into practical defense measure and understand how the malware fits into an attacker's technique. There are two main branches of malware analysis: static and dynamic. Static analysis focuses on inspecting a file without executing it, whereas dynamic analysis involves execution. We'll come to these shortly. Sandboxes. In cybersecurity, sandboxes are used to execute potentially dangerous code. Think of this as a disposable digital playpens. These sandboxes are safe, isolated environments where potentially malicious application can perform their actions without risking sensitive data or impacting other systems. The use of sandboxes is a part of golden rule in malware analysis. Never run dangerous application on devices you care about. Most of the time, sandboxes present themselves as virtual machines. Virtual machines are a popular choice for sandboxing because you can control how the system operates and benefit from the features such as snapshotting, which allows you to create and restore machine to various stages of its status. To reiterate, it is imperative to understand that potentially malicious code and applications should only be run in a safe, isolated environment. For now, this room will refer to malicious code and applications as samples. With these fundamentals covered, let's move on to the practical section of today's room. The following will demonstrate a sample. You must apply these technicals to hophelper.exe file presented to you within the hop helper folder on the desktop of the practical VM. Yeah, and we do see that hop helper folder is present there. Interactive static analysis. As we alluded to previously in the room, we use static analysis to gather information about the sample without executing it and digging deep. Static analysis can be a quick and effective way to understand how the sample may operate, as well as how it can be identified. Some of the information can be gathered from static analysis has been included in the table below. They've provided us with a table describing each of the information that we can potentially find from static analysis, or in fact, we do find this all the cases when we perform a static analysis of the application or the malware itself. So we find some checksums. These checksums are used within cybersecurity to track and catalog files and executables. For example, you can Google the checksum to see if this has been identified before. The checksum almost looks like some kind of a hash or some random characters which is unique to each of those files itself. Strings are sequence of readable characters within an executable. This could be, for example, IP address, URLs, commands, or even passwords. Yes, most of the time we do see the IP addresses, passwords, or URLs, or some commands which are related to executing those malwares to be present in the string format, and we can understand some and identify some information about those malware. Here they've given us the example of some external IP address being present in the format of strings. Imports. Imports are a list of libraries and functions that the application depends upon. For example, rather than building everything from scratch, applications will use operating system functions and libraries to interact with the OS. These are useful, especially in Windows, as they allow you to see how the application interacts with the system. Create file view or file W is basically a library used to create files on Windows systems. Resources. Resources contain data such as the icon that is displayed on the user. This is useful to examine, especially since malware might use a Word document icon to trick the user. Additionally, malware itself has been known to hide in this section. Yeah. So usually Windows macros are disabled for that reason because they can run in the background, and usually those are executing the programs or the exe files which is embedded hiddenly inside it. So yeah. However, it's important to note that regardless of how a sample may appear or function, we truly don't know until it's executed. Attackers use techniques such as obfuscation to obscure how the sample appears, primarily to evade antivirus but also evade a curious analyst. Demonstrating PeStudio. This section of the room will demonstrate the using of PeStudio on an example called downloader.exe. Please note that the information you see will be from this demonstration sample. The sample you'll be analyzing will be different, but the techniques will still apply. Please note, it is imperative that you do not launch hophelper.exe executable yet. First, we will use PeStudio to gather information about the executable. Executive summary. Launch PeStudio, load the executable into PeStudio, click on Indicators tab on the drop down, look for SHA-256 sum. Okay, so let's do that. We have the PeStudio shortcut here. Let's run that and probably get a split screen a little bigger so that we can have a better view of it. Uh, did it run anything? Or let's open this in full screen. Okay, till that's loading, let's also dig deeper into reading this. First, we will launch PeStudio and load the executable into it. Shortcut for this section has been placed on your desktop for your analyst machine. You can drag and drop the executable into the PeStudio window or load it by selecting File, Open File from the toolbar. PeStudio will display some information about the executable. Okay, let's come here, and that's still compiling something. Okay, yeah, I hope everything is ready now. Let's open the shortcut here, and it says drag it and drop it. So do we have the tool here, the downloader.exe? These are the tools. DFIR tools, hop helper. Do we see in the downloads? No. Okay, so what we'll do is let's run the hop helper.executable itself, so that we can analyze that itself as a part of the challenge here. So let's bring this here, then drag it and drop it. Now, yeah, this is one good case of analysis. But what we do is we take multiple copies of the tool. For example, there are something called as a golden copy and silver copy of the tools or the findings that we get. In this case, it is just there to demonstrate how things are going to work in. But it's also one more thing that whenever you store a malware in your system, you should store it with the executables exe or those file format being removed by it. I would like to just see. I don't know how to. Okay, it's under view and also the file name and its extension. So we can see that it's hophelper.exe, right? So I'll just copy this file, and in the desktop, just for the purpose of demonstration, whenever you're storing a malware, just go to rename and then remove these executables or those extensions of that application, then press enter, then click on yes, so that uh with a different name. Okay, so we can't do it here because we have a directory there. Let's cut this and go to downloads and place it there and rename it with hop helper. That's it. We'll remove the .exe from the location there. Now the reason for that is that by mistake, if I double click on this, it's not going to execute itself. We'll get a prompt. Whenever you're transferring or sharing these malwares between your one system to the other system, or while having them saved on your analyzing machine, it's sometimes by mistake or even intentionally, if you click on these malwares, we don't want them to execute until unless we want it to execute itself. So we remove those extensions to make sure that Windows doesn't just randomly execute those malwares while we are in between some investigation. So it's always the better case. Now, even if that's the case that we have removed the extension, we can always identify the type of malware from here. So let's exit this PeStudio and analyze this one without the extension. We get the same information that we would get if we have the extensions there. So let's drag it from here and drop it there, and we still see the same information that we get the file hash of it. We can also see it's an executable 64-bit and it has a GUI for it. Entropy is set. We can also see it's a Microsoft linker, which means that the signatures match towards running executable in a Windows environment. So all those information are still found with removing the exe of that file. Okay, let's close this once again and open PeStudio with the file that they have told us to analyze. So let's go to the desktop here, hop helper, then drag this and drop it into PeStudio to analyze them. Okay, so here they have told us to identify something. Look for the SHA-256 phi sum. Okay, so the SHA-256 phi sum is this one. This is the hash of it. Okay, I just want to go tangent. I don't know if that's present in the room where we are analyzing. Is there any known validation or known identification of these hashes? What we'll do is let's copy the value of it. And can I paste it here? Yes, I can. So we can go to virus total, and then looking at the hash of it, we can identify to see if this has been reported by virus total or any other vendors even before we are searching this or scanning this, so that we'll get a better idea about the malware that we are dealing here with. No one has reported this yet. Okay, that's interesting. It says hophelper.dll, which is nothing but an executable. Last analyst date was 2 hours ago. No one has restricted or identified this to be a malware. Okay, that's interesting. then let's just skip that. Okay, for us at this stage, file SHA-256 property within the table is of interest. The value of the checksum, which is unique identifier for the executable, we can keep a note of this SHA-256 as the threat intelligence. Okay, let's then save it. It's already here, so we don't have to save it in a different place now. Now proceed to do this on the sample hop helper.exe provided you on the analyst machine to answer the question 1. Okay, so we can answer the question 1 with that. Let's what is the SHA-256 sum of hop helper.exe? Check. And yes, that's the hash of it. Okay, now scrolling up, we see here. As a reminder, the hophelper.exe sample can be found in the hophelper folder on the desktop. Yes, we have already done that. Next, we will proceed with reviewing the strings of the executable. You can do this by clicking on the strings indicator on the left panel of the PeStudio. Okay, let's go here and go to the strings option there. So this is where we can see all the possible string that we can see in the binary here, and it's sometimes usually some random characters like this j rich or something like that, but sometimes interestingly we can also see that it's here this program cannot be run in DOS mode, or we can scroll down to see if we can find anything like an IP address, password. Here we see a set of characters. Okay, but anything specific other than some random characters here, I don't see them anywhere in the top. Okay, let's continue reading here to see what's there for us. In the context of the malware analysis, strings are sequences of readable characters presented within an executable. This could be form of, for example, IP address, URLs, commands, or even passwords. As a malware analyst, it's great to have a look at these, as these could reveal attackers' command infrastructure, which we can use for our defense. Now proceed to review the strings on the sample hop helper.exe provided to you on the analyst machine to answer the question number 2. Please know that it may take a few minutes for the strings to calculate. Okay, let's go to the question 2 and see what exactly they're asking us to find there. Within the strings hop helper, there's a flag format of this exists. What is the flag value? Now this can be found towards the bottom of the strings output. Okay, so we were on the right path itself. Let's go to the bottom by using the scroll bar here. Let's see, do we see any .thm format? I saw something. Uh, I saw something here. Okay, maybe no. Let's there's another way of getting strings. In fact, I feel that's more efficient in cases of TryHackMe's finding the flag thing. Is that you can use a tool called as strings, which does the same thing of revealing the strings that is present in the application. Okay, I don't see it here. Okay, there is a lot of strings here, so which means that we can find the flag here, somewhere here. I hope it's somewhere easily seeable when I get to the bottom of it, because I would be really bad at missing those flags even if it is present in front of my eye. So we see some IP address here. The IP addresses, I hope that's some external IP address. Okay, and we find it here. So we find the flag. Let's copy the value and paste it in there and click on check. Come on. Okay, yes, that's done. Okay, now what do we have and where did we stop? Right here. Great. This concludes the static analysis portion of the practical. There's so much more to uncover using static analysis. Feel free to explore if you would like. Let's proceed with the dynamic analysis below. Now, yeah, there are so many things. We can even see the libraries that were being used. I'm just going a little tangent. This is where we can see what the application or the exe file is trying to use for its functionalities. Basically, you would want to interact with the machine. So you would want to use some libraries to be able to interact with it. You can also see some sections. Now this goes deeper into analyzing it. So we'll not get into that right now, but we can also see a file called as manifest, in which we can see some basic and the initial part of the code present here. Okay, and there are so many things which are just missing here. uh, Again, you can just click on and then go deeper into analyzing what are all these files and sections present here. Now let me also skip that part and get into dynamic analysis. This section of the room provides a brief introduction to dynamic analysis. As you recall, dynamic analysis involves executing malicious sample to identify its behavior and how it interacts with the operating system. Regshot is a widely used utility, especially when analyzing malware on Windows. It works creating two snapshots of the registry, one before the malware is running and the other one afterwards. The results are then compared to identify any changes. Malware aims to establish persistence, meaning it sneaks to run as soon as the device is switched on. A common technique for malware is to add a run key in the registry, which is frequently used to specify which application are automatically executed when the device is powered on. Before executing the malicious snapshot, hophelper.exe, let's create a snapshot of our registry as it currently is, so we can compare difference once the sample has been executed. Let's load up the Regshot and create a snapshot of the registry as it currently exists. The shortcut of this has also been placed on the desktop for the analyst machine. First, change the output directory of the capture to the user's desktop using the box with the three dots in the output path section. Okay, for that, let's open up the auto run, no, Regshot here. Okay, we need to come here and load it. Let's load it here. Click on yes. Now, for the first shot, we need to select the file there. Output path. Okay, let's change that to the desktop. This PC desktop, and shall we create a folder here called as output? Or yeah, let's create a folder called as output. Rename, and that's going to be output. Output. Then click on OK, and that's the folder that we will be dumping our first shot in that. Okay, then once set, let's create our first snapshot. Press on first snapshot and shot in the drop down. Please note that this may take few minutes to complete. Yeah, so we can save that in the plain text itself. And okay, let's just click on first shot and shot. This is going to take the compiling. It's going to look at all the registry entries and make a list of what is the current status of it. Let's wait for it. It does take some time to create a snapshot of the machine there. Okay, I'll meet you all once the snapshot is completed. Okay, here we finish the first snapshot. As you can see, it has collected 40498 of values of registries there. It has identified so many keys. And snapshot 2 is also ready for us to deal with. Okay, let's go down here. And in fact, this, I don't know, we are not able to interact with it. So I'll just close it to that end. And yeah. Once we have executed our sample, let's run the Regshot and capture our second snapshot. Oh no, we have missed this part here. Now that we have taken the snapshot of the registry, you should proceed with executing the hophelper.exe sample and take another snapshot. We will then compare the difference. For you, this is the hophelper.exe executable located in the hophelper folder on your desktop. PSST, now that you have executed the sample, you might see that some strange things have happened. Yeah, what we'll do is we'll first execute the hop helper here in the directory. Let's click on run and wait for the malware to infect things there. Oh, wow. The King Malhare sends his regards. Thank you. Click on OK. And we see all of our exe files here have been replaced with the egg.ico. That's interesting. um, that is it. I hope there's nothing strange with it. That's it. Okay, fine. Okay. So I guess now it's the time that we take a second snapshot of it. Once you have executed our sample, let's return to the Regshot and capture the second snapshot using the same procedure as above. Click on the second snapshot button, then press on shot in the drop down. Regshot is now capturing the registry again, the outputting difference to a file. Okay, let's click on second snapshot and shot, and that's going to capture all the values there. So till that does it, let's continue reading. It says, and now after a few seconds, let's press the compare button that appears. Okay. I hope the tool doesn't crash right now. Okay, it has finished capturing the paths of the registry. Now let's click on compare, and that is going to load. So let's continue reading it and see what it gives us. We can search for executable within the log that opens up. Yeah, that's going to open up. It's taking some time. Let's wait for it to completely load up. No, it does come here. Yes, so the text, it's going to give us a text file. It says some details about the Regshot tool, which is important. If you're documenting, all these contents are important to adding it to who is auditing it, who is comparing, all the computer names, all those information. Now keys added were these four keys. It says boot check, software Windows. Now I don't know exactly what this tool is doing. So what I can currently see is that there are four added keys into the registry entry here, and these were the four parameters of it, and five were added to this location. So it says Windows software, Microsoft Windows current version run. Exactly. So this is what is happening. So it's opening the hop helper.exe file, which is present in the desktop. It's setting its location to be set as run. So that's going to make it make sure that whenever the system reboots, this file also is going to start by default. Then these are some modified values, which is nothing but it again doing some changes to the machine there. We can decode these with some editors and compare what are the differences, but I'm not going to do that right now. So let's minimize this window there. Now let's proceed with procmon. Next, we will explore using procmon, process monitor, from the sysintls suits to investigate today's sample. Process monitor is used to monitor and investigate how processes are interacting with the Windows operating system. It is a powerful tool that allows you to see exactly what process is doing. For example, reading and writing registry keys, searching for files, or creating network connections. Open Process Monitor or Procmon. The shortcut for this has been placed on the desktop of the analyst machine. Process Monitor will automatically start capturing events for various processes on the system. Okay, this is Procmon shortcut. I hope it's not corrupted by the tool or the malware. Yes, it's not corrupted. And we can straight away start seeing what are the processes that are running and what are the details of it. So we see ctf mon.exe to also be running. That's not a common executable, but I guess it's part of the tool that we have run there. So it's also interacting with rec keys, so rec query keys. Yeah, so there are many services that is running in the background. We could even see our tools that we're interacting. Where are they? So it's going to be somewhere in the top. It's Windows Explorer, Sysmon, and okay, we don't see that right here, but yeah, they all exist somewhere. We can filter them out later. Now execute the sample hop helper.exe again and return to the process monitor to see how it interacts with the operating system. You will see a lot of information here. Do not worry. We'll come on to how to filter these shortly. Okay, after allowing a minute to pass, ensure the sample has successfully executed. We will now stop capturing. To stop capturing more events, click on the play button in the toolbar to the process monitor. Okay, now it's currently running. So, no, it's not currently running. It's paused now, right? Uh, should we click on it? Yeah. So let's run this. Capture E, right? Yeah, it's now recording. Uh, what we'll do is come to hop helper, then run this file. Again, something is going to happen where icons are going to change, and we'll get a message from, yeah, King Malhare sends his regards. Thank you. Now let's open this file once again. And now let's click on this. Oh no, we should have clicked on that and then run the tool, right? I hope that's how it should be done. Anyway, let's try both. What's going to happen? We'll see that right now. I'm just scrolling up in the background here to see if there is any changes that's happening. I don't see anything. Okay, anyway, let's click on OK. And now click on this. Now it has stopped recording. Or it has now started to record. I am not sure. It's been a while that I've used this tool, so yeah. Okay, as you can see, there's a lot of information scrolling through here. The most recent events are at the bottom. Here we can see how various system processes are interacting with the windows. Nearly all of it. We don't care about. Remember, the task content is demonstrating using process monitor for the demonstration sample downloader.exe. You will need to follow along, but doing so for the hop helper.exe. Okay, let's go to the bottom of this and see what recent files were being shown. This is quite big, so let's go to the complete bottom of it. We can see we host exes to be running there. Okay, and we are seeing some TCP send operations happening. Is it communicating somewhere to some external location, or I'm not sure. Okay, let's filter it. Let's come to filter and filter. Let's also follow along with that. A new window opens. Yes. Here we can create some filters to remove some of the noise that we don't care about, because we want to only look for downloader.exe sample for the demonstration. We can apply the filter like apply process name filter. Set the condition is put the name of the processor we wish to see within the text area, press add button, apply to this filter, and finally click on OK to save. Now that's a lot of information, but let's come here and let's come here and click on the process name, and the process name we can click on is, and here we can add the value. The third one is to put the name of the processes we wish to see in the text area. Are there any process lists that we can see? We can see some executables. What we'll do is we can go to hop helper. Is that present there? Yeah, hop helper.exe. I'm sorry. Hop helper.exe is here. Then click on include. Yeah. Then click on add. Click on apply, and we can see those information to be present there. Once we are done the main process window, we can already see the filter has worked. Yeah, so let's click on OK, and we can see the hop helpers exe files to be present there. And this shows a lot of activities that is done by hop helper. We can see it is interacting with the registry entries and doing some changes there. Also, we can see the results of those changes that is happening. Not only that, we can see it's using wsync, or that's some file, and also loading some images there, closing those files, opening those files. All those is happening by hop helper.exe file. Okay, let's continue reading here. Now it's much easier to investigate how the process is interacting with the operating system. Here are some operations that may be of interest to us. Reg open key, create file, TCP connect, and TCP receive. TCP connect is basically to connect to an external source, and TCP receive is nothing but taking in information from that file or that server. However, as you can see, there is still a lot of information. We can further apply filters to look for specific things that we want to investigate, such as the aforementioned operations. To do so, return to the filter heading and create a filter we want to apply. For example, we can filter by operations. Let's do so below, filtering any TCP operation. Okay, for that, let's come back to filter once again, then go to operation, then here for the TCP operation. Where is TCP? What exactly in TCP? Have they specified it here? It's just TCP. Okay. Uh, do we see just TCP here? No. Let's click on TCP accept. Okay, anything which has TCP, that's fine. Click on add and click on apply. Click on okay. Yeah, we don't see anything because there is nothing like that. Um, let's go to operations once again. Then click on. Let's look at some TCP that's going and coming. So send, or we have seen connect, right? So let's go for TCP connect itself. Click on add, then click on apply. Okay. Yeah, we see one TCP connect that is going on to some location there. Okay, that's interesting. Um, yeah, now we will now see all operations that includes TCP. Remember, you can remove the filter you have previously applied by pressing the filter list and then pressing remove. Or alternatively, if you wish to start over, you can simply press reset filters option, then clicking the filter heading. Okay. Phew, well done. That concludes the demonstration for today's room. Remember, you will need to apply what you have learned on the hop helper.exe executable that has been placed in the hop helper folder for analyst desktop. To answer the questions below, let's go to dynamic analysis section. What registry value has hop helper.exe modified for persistence? Provide the full path for the full key that has been modified. Now, for persistence, we already saw that it's the run command that is present here. Let's copy this entire location. Yes, just that one line. Copy. I've missed out H, which I can just add it there and then place it. Check that. Yes, that's done. Now, dynamic analysis, filter the output for Procmon for TCP operation. What network protocol is hop helper using to communicate? Make sure you have executed hop helper while Procmon was open and capturing events. It Yeah, let's go through that. TCP connect is what is the operation which is identified here. Let's run this and also change some filters here. Let's first thing is let's reset all the filters. Okay, now let's filter for operations once again. Where's operations here? Operation, then yeah, is, and there is no TCP specifically. I'm not sure. Then how did they just get that there? Um, okay, let's click on TCP. It's what is the question here? Let's go to this window. What's the question here? Uh, what is the output of Procmon for operation? What network protocol is this using to communicate? So communicating means it's trying to accept or connect itself. So we can use that. Click on add, click on apply. Okay. It's using operation is happening here. We don't We see it's HTTP is what is being used there. So we can enter HTTP, press check, and that's the right thing. Okay, bonus. Can you find web panel that hophelper.exe is communicating with? Yes, we do get the panel here that it's communicating. Batch blocker sandbox, that's the domain. Is that right? It seems the executable is communicating to some information about the analysis machine. Can you find where and what? Yeah, we did. Okay, is this how hints are going to be displayed to us? Uh, it seems okay. Okay. I guess that did not give me anything useful. But anyway, let's click on the correct answer. Then, if you have enjoyed today's room, feel free to explore both the machines. Basic static. Come on, just close it. Basic static analysis and basic dynamic analysis room, where you can delve deeper into techniques and tools discussed today. Yes, I would love to, but right now let's click on check and finish today's challenge there. And yeah, that is it for malware analysis of the day 6 of Advent of Cyber. This is in fact fun. Let's someday take a deeper look into malware analysis on my channel, looking at some actual malwares and how we do some malware analysis using different tools. Okay, till then, stay happy, stay smiling. Thank you for watching. Thank you. See you tomorrow with the day 7 of Advent of Cyber. Thank you for watching. Bye bye.